Okay, let's cover scoping rules. Here's some related reading. So scoping and binding are the way R looks up objects and names. So all objects that you create and store in an R session are stored in what's known as the workspace or the global environment. So, when you create a vector and you assign it to, say, the name X, it creates an object and it's held in the global environment. When you run a function, however, a function creates what's known as a local environment. Okay, so it's kind of like a separate little sandbox, and within that function, you might create values, you might create other objects and things like that. Those things exist only in that little sandbox. And objects created locally in that sandbox don't appear in the global environment. And then as R is looking for values, okay, basically the values that exist inside the local environment take precedence over values or objects with the same name in the global environment. So that's called object masking. So if you have a vector X in the global environment, but then within the function, there's also another vector named X, okay, that object inside the function will mask, okay, meaning whenever somebody calls for the name X, it takes place over what exists in the global environment. Okay, so the object name within the function will reference the local object instead of the global one. So yeah, let's just look at this very simple line of code where I create a vector 1, 2, 3, and I store it as X. All right. So the way we often think of this is that we're creating an object X, and that object X contains the values 1, 2, 3. But technically, the way this works, okay, is that this object with the vector 1, 2, 3 is created somewhere in memory. Okay, it creates a vector with the values 1, 2, 3 somewhere in memory, and then the name X, okay, is bound to that object, or the object is bound to the name X. The assignment operator just associates the name X to that object. And so therefore, when you ask R to find the object X, it looks up it sees that name points to the location in memory, okay, and it then gets the values 1, 2, 3 from the location in memory, okay. So then what happens here, okay? So here I create the object 1, 2, 3, okay, and I assign it to X, all right, or I bind the name X to that object. Then I bind the name Y to the object X, all right. Over here we create a vector 1, 2, 3, and we bind the name Z here. So what's the difference between Y and Z? When you ask R for what is Y, it's going to output 1, 2, 3. When you ask R for what is Z, it's going to output 1, 2, 3. Okay, but technically, these are two separate objects. Okay, one is 1, 2, 3, and the name X is associated to that object, and the name Y is associated to the same object. Okay, then we have a separate vector 1, 2, 3, and the name Z, okay, points to this object that has the values 1, 2, 3. Okay, so Y and X are pointing to the same object that we first created. It's a vector containing the values 1, 2, 3. Okay, and then that third line of code creates another object with the vector 1, 2, 3, but it binds the name Z to it. Okay, and then if you say remove an object or something, delete things, then R has its own kind of garbage collector, and it manages memory on its own. So it's something you don't have to worry about. Versus, other languages like in C where, you create objects and then you have to kind of get rid of them also. Otherwise, the these things take up more and more memory. Okay. What one thing that R does, though, is it has copy on modify syntax. Okay, meaning let's look at what happens here. We create a vector 1, 2, 3 in memory. We bind the name x to it. Okay, I bind the name y to x. So y and x are both pointing. So I've got x, it's pointing to this. I've got y, it's pointing to the same object. Okay, but then on line 3, I say take the third value in y and basically put 4 in there, right? So we are going to modify the value of the third object or the third element in y, okay, to 4. And what this does is when R sees that we're changing the value of y, it creates a copy. So as soon as when R sees this line, a bunch of stuff happens under the hood. It creates a copy of the object. So x is still pointing to the first thing that has 1, 2, 3. Okay, but then y gets modified, and now it says 1, 2, 4. Okay, so y now points to a different object where the third value has been changed to 4. So x still shows 1, 2, 3, but y shows 1, 2, 4. So assignment is the idea of binding the name to a value. Scoping is finding the value associated with the name. The scope of a variable is the region of the code where that variable is defined, where when you ask for an object X, it's able to find it and return the thing, right? If R can't find it, it says, object X not found. And the basic scoping rules are pretty simple in that it's going to look for the thing, and if it can't find it, it searches in a higher scope. So let's take a look at this, and remember, objects within a function are created in a local environment, and those take precedence over the global environment. So what happens here? So what is going to be the output of g of 3? So we have y in the global environment gets 1, okay, is bound to the value 1. Inside g, we create a function. It's a function of x, meaning when we run g of 3, x is going to get the value 3. Inside the function, y gets the value 2. And then the function, the very last line of the function, it returns the value x plus y. So what we're going to get back is 3 gets passed in as the value for x. And then when it looks for what is the value of y, it finds the value 2 inside the function's local environment. So we're going to have 3 plus 2, and it's going to return the value 5. Okay, so names defined inside the function mask the names outside. So when we get y gets bound to the name 2 here in the local environment, it's going to find that value 2 in the current local environment. So yeah, g of 3 returns 5. Okay, and that's all explained here. G is passed in as the argument, 3 is passed in as the argument x. Function returns x plus y. X has the value 3, and the value of y finds 2. This value of y being 1 in the global environment is irrelevant as far as the operation of this function. Okay. The main scoping rule in R is lexical scoping, and that is basically if R can't find a variable in the function's function body scope, it will look for it in the next higher scope, and so on. And in general, when you write functions, you don't want to have to use R's lexical scoping rules, rely on it all the time. So it's generally considered poor technique to reference objects or values that are not defined inside the function. But R was designed for statistics first, and then programming secondary. So R does not require good kind of programming habits, and so you can do stuff like reference values that are not defined inside the function, and R will just try to do its best. Okay, and so that's kind of how R works. R tries to do its best in a lot of situations, and a lot of times it does pretty well. But again, it's better to try to avoid these things and have good practice. But anyway, let's make sure we understand the lexical scoping rules. Okay, so here we're going to pretend we're going to clear everything out of our environment. We're going to bind the value 1 to the name y. Okay, and now we're going to have a function of f of x, function of x, and this function is going to search for x plus, or it's going to return x plus y. So when we run f of 3, the way it's going to execute is 3 gets passed in as x. So when it runs line 3, we have x has the value 3 because that's what it gets passed in at this function, and then it says, okay, I need y. There's no y inside the local environment of f. Okay, so when it can't find it inside the local sandbox, it searches the higher scope and it finds 1 in the global environment, so it's going to return 4. Okay, so again, variables defined within a scope only exist in that scope and only for the duration of that scope. If variables exist with the same name outside the scope, those variables and those objects are separate and don't interact with the variables or objects inside the scope. They're not overwritten, they're not modified, okay? So you just have to remember a function is its own separate environment, and really the only way functions communicate with, say, the quote outside world or the global environment is via the arguments that go into the function when you call it, and then the object that gets returned goes out. So that's really the only way the function interacts with the outside world. So what happens inside the function pretty much stays inside that function. So, for example, if inside the function you decide to run this command, rmlist equals ls, which basically deletes all of the objects, okay, you delete only the objects that have been defined inside the function. This is something you should never do, because basically when you call the function and you pass arguments, all of those arguments get created inside the function, then rmlist equals ls would delete all of those things, so you've lost them all. But that just illustrates that it only affects basically the local sandbox, okay? There is a assignment operator known as super assignment. It's this kind of double arrow, and that basically searches and assigns things to the higher scope. It's a dangerous operator, and I recommend not using it. I will cover how it works, and I think it's important that you understand how it works. But in general, you shouldn't be using it. Okay. All right. Let's take a look at a couple examples. So here I create x, y, and z. They all have the values 1 in the global environment. Okay. And then I create a function f. F is defined inside the global environment, and then look at this. We're going to create g inside of f, okay? Within f, we create a value 2, okay? And it gets assigned to the name y. And then within f, we create a function g, okay? And then inside g, 3 gets assigned to the name z gets bound to the value 3. And g is going to return x plus y plus z, okay? And then meanwhile, f, it returns what g returns. So it calls g and it returns whatever g returns. So if we run f, what is it going to return? And then after running f, what are the values of x, y, and z in the global environment? Okay, so let's think about this. So when I run f, I'm going to assign 2 to y, and then basically I'm going to create g, but not run it. But then when I run the last line at line 10, I'm going to execute g. Okay, I call g. So now I go and I execute g, and we assign z to 3. And g is going to return x plus y plus z. So it looks for x at first. It doesn't find it inside the local scope of g. So it searches the higher scope, which is now inside the function f. It doesn't find z there. So it goes to the global environment and it finds z as 1. Then we look for y. X. It finds x as 1 in the global environment. Then we look for y. And it looks for y inside of g. Doesn't find it. Goes to the higher scope. It finds y is 2. So it's going to take the 2 and put that there. And then lastly, it looks for z. And it finds z in the local thing. So we're going to have 1 plus 2 plus 3. G is going to return 6. So that gets put here. And now f returns 6. So f is going to return the value 6. After running f, what are the values of x, y, and z? They're going to remain 1, 1, and 1 in the global environment because none of these assignment operators affect anything in the higher scopes. Okay, so we have f is 6, and x, y, and z are 1, 1, and 1. Okay, let's talk about super assignment. So regular assignment operator always creates objects inside the local environment. Super assignment never creates a variable in the current environment, but instead what it tries to do is it modifies an existing variable found in the parent environment. If that super assignment operator doesn't find an existing variable in the parent environment, what it does is it climbs kind of the scoping ladder until it finds the variable that it's looking for. Eventually, if it reaches the global environment without finding the variable, then it's going to create that variable in the global environment. As a kind of guideline, you should avoid super assignment. Like in homework 2, as you're thinking about your things, you might be like, oh, it would be so tempting to use super assignment, because sometimes you think, it can make my problems easier. And sometimes it can, but then also it can also make things a lot harder to debug. So just be careful, just be mindful of that. Okay, so let's take a look. So I'm going to create x, y, and z to get the values 1 in the global environment. And then I create a function f, and inside the function f I use the super assignment operator. We're going to bind 3 to the name y. And so what this does is it does not create y inside the local environment, but it immediately goes to the higher environment and it does that. Okay, and we're going to then return the value y. Okay, so when we run this, okay, so when I run lines 1 through 5 here, it creates x, y, and z in the global environment, and it creates the function f, but it hasn't executed it yet. So if I ask for what are x, y, and z, right now they are 1. Okay, then I call f. When I call f, then it runs these lines of code, and so now y gets modified to be 3 in the global environment, and then it returns y, and when it looks for y, it's not going to find y in the local environment because y is not created in the local environment. Okay, but it will find y in the global environment, and it's going to get the value 3. So f is going to return the value 3, and when we check what are x, y, and z in the global environment, we can see y now has the value 3. Okay, so let's take a look at this function in a function business here. So first we create x, y, and z to get the values 1 in the global environment. Then we have the function f. We modify the value of y in the higher scope. Okay, so when f gets executed, y in the global environment will take on the value 2. Okay, and then f is going to return g. So when we execute g, what is it going to do? G is going to look for z. It's going to try to modify z in the higher scope. It doesn't find it inside the scope of f, so it climbs the higher scope and eventually finds z in the global environment. And so it modifies z in the global environment to be 3. Then it returns x plus y plus z. It looks for x, doesn't find it inside of the local environment of g, doesn't find it in the local environment of f, finds it in the global environment, gets the value 1. Then it looks for y, doesn't find it in the local environment of g, does not find it in the local environment of f, because remember this doesn't create it in f, it modifies it. So it goes to the global environment, and it finds that by this time y has been modified to the value 2 in the global environment. And then lastly, it looks for z, doesn't find it in g, doesn't find it in f, goes to the global environment and finds that z has the value 3 because it got modified when it ran this. So it's going to return 6, and then when we check for what are x, y, and z in the global environment, it has the values 1, 2, and 3. Okay, so make sure you understand the difference between this line of code, this set of code, and this thing, which are very, very similar. Okay, the way they're written, it's just we've changed basically the operator here to be super assignment and the operator here to be super assignment over here. And then the result is that we get 1, 2, and 3 in the global environment. after G gets executed. A few things can happen though, and super assignment can be tricky, right? So here, note this is just bad practice, okay? So you shouldn't do this intentionally, but you might do this unintentionally and then confuse yourself. So I'm going to create x, y, and z in the global environment. They each get the value 1. We're going to create a local variable y inside the function f. And then we use super assignment, which will modify the value y, but in the higher environment, which will be up here in the global environment. So y is going to get the value 4 in the global environment. Okay, we modify z. Z is going to get changed to 3 in the global environment. Okay, so now we're going to return x, y, and z. We look for x, doesn't exist in G, doesn't exist in F, finds it in the global environment. X has 1. Now we look for y, doesn't exist in the local environment of G, but it does exist in the local environment of F. So we're going to take that. Y is going to get the value 2. Then we look for z. Doesn't exist in the local environment of G, doesn't exist in the local environment of F. We find it in the global environment. It has the value 4. So z has the value 3. So when we check, F returns the value 6, and x, y, and z have the values 1, 4, and 3. Okay, so let's look at this again. Okay, so now I have x, y, z in the global environment has the values 1. I create a local value of y in F, 2. Local value of z in 10 gets 10 in F. All right, and then we modify y in the higher scope. Y gets the value 4, and then when G gets executed, then this super assignment is going to modify the z in the higher scope. It finds it in F, and so this is going to get modified to 3, and it doesn't touch the global environment Z. So now when we return x, y, and z, it's going to look for x, not in G, not in F, finds it in the global. X has 1. When we look for y, it's not in G, but we find it in F, gets the value 2. Then when we look for z, it's not in G, but we find it in F, and F, the z inside F has been modified to the value 3. So again, we get 1 plus 2 plus 3, it returns 6. So when we execute F, it's going to return 6. When we ask what is x, y, and z in the global environment, x has the value 1, y has been modified to 4, and z remains 1. It was never touched by this super assignment operator. So we're going to get 6 and 1, 4, 1. This is why I say you should avoid using super assignment, okay? Because sometimes things get confusing. So let's say you want to run and kind of take the output of, let's say you have argument foo or whatever, okay? And you want to add a squared thing. So we're going to take in some object, and then we're going to kind of append the value of x squared to it. So we're going to take foo, we're going to append x squared to it, and super assign that back to foo. So here I start off with foo being 2. Then I run this function. I'm going to do foo and 5. And then so when we do this, okay, it passes the value 2 into foo, okay. Then it takes x, which is 5. It squares that 25, creates a vector with 2, combines 2 and 25 together, and it super assigns that back to foo. All right, and so when I ask, hey, what is the value of foo? We get 225. So this kind of seems like it works. All right, let's try this. Now I have an argument bar, 10, okay, and we're going to run the same function, bar and 6. So based on the way we've written it, we're expecting it to be the value 10 with the value 36 appended, okay? But that's not what happens. Bar remains 10, and instead foo has been changed to 10 and 36. Okay? Foo has been changed to 10 and 36. Because what happened when you look at this super assignment, okay, it takes the name foo here, okay, so this time the value 10 got passed in, right, and it gets passed in here, so we get 10 and x is 6, and it gets 10 and 36, but then it super assigns it back to foo in the global environment. It's not the local foo, it's the foo in the global environment. So the foo in the global environment ends up getting the values 10 and 36, okay? So a better way to handle this, okay, is just to have the argument, have it return, you know, here I've got baz and x squared, okay? And then you just have to explicitly assign it. So here I'm going to take 2, we're going to do foo and 5, and then we ask for what is foo, it gives me 2 and 25. Here I have bar is 10, I do bar and 5, and it returns 10 and 25, okay? The key difference here is I have to use the regular assignment. So after running the function, I have to make sure I capture that output by assigning it back to bar, okay? Whereas, you know, super assignment, you didn't need to do that. You can just run foo and then call the function and it modifies it, okay? But again, this kind of stuff can lead to kind of confusing results because this is always going to modify the object foo, so you can't really put in other kinds of names or objects there. Okay, so in general, try to avoid using super assignment, but you do sometimes read other people's code and you do see super assignment being used, and so it is important to still know that it exists and know how it works.